which is closer to 6 months. And you have to be really careful if people come over. 4, 18? Okay, we're taking about 3 pages of notes. Just be ready.
Oh, wow.
Our central question is on the board, but our title is kind of long. So it's still trig functions. I'm going to abbreviate. In the coordinate plane. So kind of like what we did the other day, right? And Pythag identity. So it's still the same thing as like what we did the other day, trig functions in all quadrants. It's trig functions in the coordinate plane. Same thing, but we're adding in Pythag identity.
Oh, did I share it over here?
Was it what?
Yeah.
Was it 0.5 line?
Yeah.
That's why. All right, we good? Here we go. Yes, sir. Remember this? We're going to do some more of this. Oh, I'm switching it up a little, though. It's kind of a... Have you watched the YouTube?
Yeah, but it was kind of hard to understand stuff.
Alright, our central question is, how do I solve? Right triangles, using trig functions. In the coordinate plane. And the trig identity. Oh, Pythag identity, sorry. That's not what I want. Stop it. You know when you click on something, you know that's not what you want. Okay, ready? Zooming in. Alright. Trig in the coordinate plane, let's start with that. If I'm doing trig in a coordinate plane, then I probably need a what? Yeah, good, yeah, good. Coordinate plane. X and Y. Alright, where is the first quadrant located, ladies and gentlemen?
Top right.
Top right. In the first quadrant, your x's are what? Positive or negative?
Positive.
And your y's are? Good. Second quadrant is located where?
Top left.
Top left. X's are?
Negative.
Very good. And your y's are? Good. This is the most important part you need to remember for later on. Doesn't seem like you do, but you do, okay? Quadrant 3 is located down here. Yes? X's are?
Negative.
And y's are? Good. Quadrant 4 is over here. X's are? And y's are? Good. The steps. Okay, same step kind of like the other day. What's the first step you had to do? Draw a what?
Like from 0, 0.
Well, the line was there last time, but we have to draw the triangle now. So we're actually going to draw the triangle based on the trig function in the given quadrant. So if it says to draw in quadrant 1, then I'm going to draw it in quadrant 1. If it says to draw in quadrant 3, then I'm going to draw in quadrant 3. Okay? Second step. Let's think about this. What did we do the other day? We drew the line, we had the line, we drew the triangle in terms of x, right? And then we found our what? We found our hypotenuse using what? Pythagorean theorem. So now we're still going to use Pythagorean theorem, but we might not be finding the hypotenuse. We might be just finding any side. Do you understand? So we're going to use the Pythagorean theorem to find the missing side. Whichever side that is, I'm going to find it. Okay? We good? We shouldn't have to write Pythagorean theorem because I know what it is. Step 3. Then you find the missing what? We already found the missing side, so now to find the missing. Do we actually find the angles or do we find ratios? Ratios. Trig ratios to be exact. Okay? Example 1 is going to be based on trig and coordinate plane. Alright? So all of example 1, so I'm going to have a couple of them. They're going to be based on this one right here. Then I'm going to do Pythag identity, then I'll do another example. Our example is going to say sine of theta equals 5 over 12 in quadrant 1. Sine of theta equals 5 over 12 in quadrant 1. What do you think the first thing is going to do? We wrote the steps. It's the first step. So we have to draw a triangle, so it means it needs to be in a coordinate what? Coordinate plane. So here's a coordinate plane. Here's x, here's y. We're drawing a triangle, yes? What kind of triangle? A right triangle, because all of them are right. Theta is located where?
0, 0 on the origin.
In the origin. Make sure it's touching the x-axis, correct? I don't want people to draw it over here or down here, right? Okay, now let's think. First of all, let's make our little chart. So sine of theta, cosine theta, tangent theta. Yes? Sine is opposite over hypotenuse. Cosine? Adjacent over hypotenuse and tangent? Opposite over adjacent. Very good. Now, ladies and gentlemen, they have given me sine of theta. They told me it's 5 over 12. Correct? So where is 5 over 12 going? Opposite and hypotenuse. So fill it in. Right? Understood?
Yeah.
So 5 and 12. This is opposite hypotenuse. Yes? That is nothing new. Now, if this is 12, that it's also what? 12. And if this is 5, this is also 5. Got it? Makes sense. Okay, when you're looking at theta, bless you, it says opposite, which is located where? Where's opposite of theta? On the triangle. The x-axis? It's right here, yeah? Okay, so that's how much? 5. And it told me my hypotenuse, which is located across from what? The 90-degree angle is how much? 12. So what am I finding? The adjacent. Does that make sense? Okay. So let's find adjacent. So we do c squared equals a squared plus b squared. What's c? Okay? What's a? Plus x squared. What is 12 squared? What's 5 squared? Equals. What do you do now? Subtract 25, what do you get? 119 equals x squared. Now what? You square root it. So x equals what? Square root of 119. Radical's a symbol. Alright, now what? Yeah. Okay, so we did step 1, so draw the triangle. Step 2 said use Pythagorean theorem. We did that. Step 3 says find the missing trig ratios. Alright, let's do that. So we already had sine, so we don't need sine. We need cosine theta, which is radical 119 over 12. Was there anything to do with that? No, wonderful, that's cosine theta. Tangent theta is 5 over radical 119. Can I leave it like that?
No.
What do you multiply by?
Radical 119.
On top and bottom. Right? Okay. So tangent theta is 5 radical 119 over 119. Can you reduce 5 and 119? Okay. Questions? Good. Next one. Bless you. Another example. Oh, excuse me. Example B. I have 3 of these, so 2 more of this. Tangent theta equals 24 over 7 in quadrant 3. What is the first thing you're going to do? Draw a coordinate plane. Sir. Alright, you should have your quadrants, your coordinate plane, and you should have a triangle, yes? What quadrant are we in? Third. Should look something like this. I should see theta inside, yes? Okay, then I should have this lovely little chart, make my life easy. Sine theta, cosine theta, tangent theta. Oh, my choice, special. Opposite is what? 24. Adjacent is what? 7. Okay, now ladies and gentlemen, let's listen very carefully. We are in what quadrant? Third. So let's look at it. Theta is here, correct? Opposite is how much?
24.
24. What value does this represent though? X or Y?
Oh.
Y. What did I say Y had to be? Negative. So this is not a positive 24, it's what? Negative 24. 7 represents what? Negative 7, because that's also your adjacent, which is located here, correct? Okay, now, why are they negative? Because they're in quadrant 3. The hypotenuse is always what, though? Positive. So some of you need to stop and think, because I'm giving you information that you should probably be writing. Your hypotenuse is always positive, doesn't matter what quadrant you're in. But your x and y values do determine. Yes? They change, depending where I'm at. Why is tangent shown as a positive answer? Why is tangent positive? Because 2 negatives make a positive. So when I write it over here, it's really negative 7, negative 24, negative 24, and negative 7. They cancel each other out when I write the tangent ratio, correct?
Yeah.
But I need to be careful. Make sense? Okay.
How do they cancel out again?
Is a negative over a negative is a positive? Yes. Yes, because it's going to change your sine and cosine. It's not going to change my tangent, but it's going to change my sine and cosine. You could, but
It's just throwing me off.
then don't write it on tangent, but you do have to write it on sine and cosine. All right, so then we have to do what?
Find the hypotenuse.
Find the hypotenuse. So x squared equals 24 squared, negative 24 squared, doesn't really matter, plus negative 7 squared. What's 24 squared? 576 plus 49. So you get x squared equals 625, and that's a perfect square. You shouldn't need a calculator, so x is what? 25. What's cosine, or sine theta?
Negative 24.
Good, what's cosine theta? Is there anything else? Wonderful. We good? Okay. Example C. You see how I'm just adding to what I did the other day? Okay. Example C says tangent of theta is negative 4 over 11 in quadrant 2. Draw the picture. Tangent theta is negative 4 over 11 in quadrant 2. Ready? Excuse me, coordinate plane. Here we go. Second quadrant located over here. Oops, that's a triangle. I promise. That should be dotted. Okay, theta is located inside. Tangent is opposite over adjacent. Oops, cosine. I cannot write. Okay, so opposite over adjacent each side because it's 4 over 11. So when I'm looking here, which one's 4? The one across, and 11 is located here, correct? Which one's negative? Why is it 11? Because you're x. Why do I not write negative on the bottom? Because you learned once upon a time, or you should have learned once upon a time, that we do not write. Why am I writing sign? I don't know. This looks funny. We write it this way, yes? Is it still the same thing? Yeah. So just remember that we're writing the negative on top, but it doesn't mean it's necessarily on top, okay? This is why we have to know the quadrants. All right, so it's actually negative 11, but positive 4. Got it? Okay. Hypotenuse, when you solve for hypotenuse, that doesn't change your answer because you're squaring it anyways, right? Yeah. The only thing that's changing is your sine and your cosine. Make sense? Okay. So, c squared is a squared plus b squared plus, I cannot write today. What is c squared?
X squared.
It is x squared. What's a squared? What is it? 4 squared plus negative 11 squared. What is 4 squared? 16 plus 121. X squared is 137. Square root is 130, radical 137. Good? Okay, now what? Sine of theta is 4 over radical 137. Do I leave it like that?
No.
Multiply by what? Radical 137. So sine theta is what?
4 radical 137.
And does it reduce?
No.
Okay. Cosine theta is negative 11 over radical 137. What do you do? Multiply by radical 137. So cosine theta is over radical 1. Oops, no radical. Told you I can't write today. That's a no radical. Got it? Okay. Are we good here? Ready? That's totally up to you. I don't. Ready? Let's do it. Pythag identity. All of the stuff we are doing, including trig, is very important when you get to IM3. You're not going to IM3, it is okay. Oh, for those of you not my juniors, there is a second option besides stats. It depends on you. There is algebra 2. Nichols is teaching algebra 2 as of right now. If you understood first semester, algebra 2 is kind of the way to go. If you're like, heck no, stats is the way to go. Okay? Stats is the way to go. You could do algebra 2. Okay? Mm-hmm. Who else, my juniors? A couple others. Algebra 2? Okay. You're going to do business math. That's good for you. Yeah. What?
I didn't learn anything. I had to sub the whole time.
I know. So, anyone else? Just so you know, there is that second option. And Algebra 2 Seniors is different because it's not as intense. I know Mr. Nichols is also going to do some like real life application in Algebra 2 because he can. I think he talked about like finance a little bit too, so. Okay, so I just want to give you that second option out there for some of you. Some.
Mr. Sanders, is it true that they might do some summer school classes here?
No, there's none.
We're
We're under construction. There's construction. There are no summer school classes here. None, zero. Yeah.
Is it true that this year's going to be late start?
No. Why do you guys keep hearing these stupid rumors?
Oh, we're not gonna have late start.
You will never have late start again.
Late start was, it's gone. It was so good.
Yeah,
It's gone.
It's dead.
It's dead.
Why?
No.
Dead.
Yeah.
Because we get out early.
I don't like it at all. Late start. I'd rather get out early.
You're still here.
Hmm?
That's because you're still here.
Yeah, we still have to be here, but I don't work very good in the morning versus in the afternoon, personally. Plus, I'd rather you guys be done and out than have to meet and then deal, like, no offense, it's better to get out early. Plus, we gotta have minimum days. You can't have a late start with, like, that doesn't make sense. So, it's just easier.
Last year it was fun. Literally, I got to sleep in one day.
Yeah, people were still super late to school.
Yeah.
Yes.
That was the only day I was on time to school.
No.
How did you know you were? You had a first period together. You didn't know what to say? You're allowed to do like sign the same. You're right. I swear, he would say
I
that.
could miss like a whole week of school. Not even kidding. I could miss a whole week of first period last year, and I'd still be passing the C. I wouldn't even take a test, and I'd still be passing. I'm like,
I think Mr. B's trying to get me to IM2 next year.
yeah.
Yes, Mr. B, yes.
What?
I think Mr. B's trying to get me to IM3 next year.
His robotics?
Yeah, I want to be doing it this year, but he only has it during fourth period. And
Yes.
I'm running for president. I'm doing it again.
Class president?
Yeah.
Okay.
You're like, what?
All right, ready? Cosine squared theta plus sine squared theta equals what? Did you write it down?
Yes. I still have to.
Okay. Cosine squared theta just means that you are doing cosine theta times cosine theta, right? That's a multiplication. I don't know why that dot is there. But we don't write squared after the theta because we're not squaring the angle, we're squaring the operation. Do you understand? So it doesn't make sense to write cosine theta squared because we're not squaring the angle. Okay? And if you wrote it over there, it'd be squaring the angle. So we write cosine squared theta instead of cosine theta squared. That's what it means, right? It just means you're multiplying it how many times? Twice. Same with sine. You have sine how many times? Twice. Okay? Good? All right, let's do an example. Oh, I have to write something down. Sorry. Let's put it at the top. Let's put a little note. Quadrant 1 answers are positive. Quadrant 3 answers are negative. All right. Questions? All right, let's do this. Our example says to find cosine theta if sine theta is 3 over 5 in quadrant 1. Find cosine theta if sine theta is 3 over 5 in quadrant 1. What are we looking for? Cosine theta. Ready? So do I have cosine theta? No. So I have cosine squared theta? No, equals, plus. Plus. Do I have sine?
Yes.
What is it? 3 over 5. But we have to do what with it? You have to square it. Because it said squared up here, yeah? Okay, equals 1. What's 3 over 5 squared? 9 over 25. What are you going to do to both sides? We're solving for cosine. So what do we do? Subtract 9 over 25. Now, I have 1, and I'm going to subtract 9 over 25. But I don't want to leave it 1 because it doesn't make sense. So how do I make this
25 over 25.
25 over 25? Which would be put in 1 and then multiply. So why is it 25 over 25? Because your denominator is what? 25. So if my denominator is 36, then my fraction's what? 36 over 36. Do you understand? Okay, subtract 25 minus 9. 16 over 25. Is that my answer? I have to do what? Square root it. And when I learned in first semester that a square root like this can be broken up into how many? 2. Radical 16 over radical 25. Yes? What is the square root of 16? What is the square root of 25? What quadrant are we in?
1.
There you go. Because I need to subtract 1 minus 9 over 25. And you have to have common denominators in order to subtract. And isn't 25 over 25 1?
Okay, so it has to be the same thing. You just subtract them and be able to square it.
All right, listen up. While I'm passing out the homework, listen. 1 through 8, thank you. 1 through 8 is like examples A, B, and C. 1 through 8 is like examples A, B, and C. The last example is like the very bottom. All right. Once you get your homework, you can go. If you have questions, you can send me a reminder. Or I'll see you at lunch in 303.
Jesus.